Hi folks, today I bring another panel to our list. I don't know which device it belonged. If anyone identifies it, as usual, I ask you to leave in the comments. Let us look at the driver that is used to interface with the VFD. It is an IC reference L9206 from the brand OKI. Thirdly, the datasheet is available online, which is a great help. This is a driver with SOP64 encapsulation, but it also appears to exist with QFP64. It has an internal ASCII table, which makes it easier for us to send the text in direct mode. We can create symbols as has already been done in the other drivers identical, filling in the 5x7 matrix, making it is possible to create one animation like the invaders or Pac-Man. The datasheet is accessible even so we must remain alert to the inconsistencies or lapse such as happened to the definition of the command to define the number of digits. The driver has two general purpose input-output pins marked as P1 and P2 that come direct from pin 1 and 2, and on this panel they connect at least one to control two green and red SMD LEDs. It is also worth highlighting the presence of the two additional anodes on the pins 3 and 4 labeled as AD1 and AD2. In the total, we are able to control 35 segments distributed across 16 grids. The power supply for the segments and the grids is up to a maximum of the less 80 volts. They recommend a value lower than less 20 volts. In our setup, we use two DC-DC converters, one of the plus 5 volts to the plus 24 and other of the plus 5 volts to plus 12 volts, in serial to get less 36 volts DC. Because the power up of our setup is only done with the plus 5 volts DC, we use a third converter of the plus 5 volts to the plus 5 volts to power up the filament, and on this way we got three total independent power supplies. Plus 5 volts DC of the power source more one DC-DC converter to filament through two diodes 1N4004 and the less 36 volts DC, which a result of the association in series of the two converters DC-DC. The usual connections are data in, clock, chip select, and reset. We can leave the reset at the high value with a resistance of the 1K at plus 5 volts DC if we do not want to use the pin 12 of the Arduino defined for this purpose in the code. Of course, we have a GND and a plus 5 volts DC for power supply, and the GND must be also used to create the reference for the DC-DC converters and the Arduino or another MCU you use. With these small steps, we can easily bring our panel to life. The panel don't have the infrared receiver, but the base of the code already have implemented the functions to read the infrared. By this reason, I had an infrared receiver in the breadboard here, and the code keep the same functions. If I press the button 1, I receive one message. Button number 2, another message. 3, 4, and so on. Okay, you can adapt to the functions you need. in the code. The infrared command I used to perform the test, in this case, is a command of the Sony. If you use another manufacturer of the command infrared, you need to adapt the code to understand the message you send, okay? But this is only change the value present in the code.